Hello, my name is Justin Robert Lentz, and I am designing a new type of spaceship that I'm very enthusiastic about. Um, I'll go over some numbers with you, and then I'll make some comparisons, and then I will go over all of the major components with you using a 3D model that I made. Okay, so I call the spaceship the Gyro Bullet, and a SpaceX rocket goes 17,500 miles per hour, which takes 6 months to get to Mars. It uses $1 million worth of fuel just to get to outer space. And my spaceship will be using C4 as the fuel. So 80% or so of the weight of a rocket is the fuel. And with my spaceship, it's much, much less and much, much cheaper. So there'll be 1,500 six-inch fuel balls that are used, and um, each one of those in space, if you multiply the speed boost of each explosion from the fuel balls, and there'll be 1,500 fuel balls, and you'll use roughly 300 to get to space. That gives you a total speed of 31,200,000 miles an hour total, but you'll be using half of that to get where you're going and the other half back, so it will be closer to 15,600,000 miles an hour. I've also designed a type of force field for the spaceship, and I'll be going over that with you too, so that space debris can't harm the gyro bullet moving at the speed that it does. um, so without any further ado, I'm going to give you the gyro bullet spaceship. I have a house here to with compare the size. It's much smaller than a rocket, and the first thing we're going to take a look at is the windshield. The windshield will crank open like an old car, and the point of that is so that it won't use any battery power, requiring less battery power to operate. And once it cranks open, this the astronauts, once they touch down on Mars or the moon or wherever they're going, it'll just be a little rope ladder that unfolds so that they can climb down and get out of the spaceship. So the next thing I'm going to want to go over about the spaceship is the flight controls. So you're going to be in the spaceship, and you're going to have a steering wheel like this. And when you push forward, what will happen is this rocket here will engage, and the top one on the backside will engage, and that will shift the spaceship in that direction. And when you pull back, it'll be the opposite. This top rocket will fire, steering rocket will fire, and so will the bottom one on the backside. And when you turn the wheel this way, what will happen is this rocket will engage, and so will this one, tilting the ship in that direction, and the same thing going the other way with the other rockets. And you'll have a button here, and what that does is it'll move a robotic motor that is on radio control frequency like everything else, and you'll hit that button, and what will happen is the flap will turn this way, causing this rocket's thrust to catch on the edge of the flap so that it rotates the ship. And then going the other direction with this button, the flaps will just move the other way, causing the ship to rotate. And how this ship lands is you turn it around and you fire a few fuel balls going in the opposite direction to slow it down. The landing part of the spaceship is going to be different. There's going to be a pilot that is facing one way for flying the spaceship, and then there's going to be another pilot who lands the spaceship. So with the landing pilot, you'll have you'll have a robotic leveling system so that it's coming down slowly on rockets that are at the bottom of the arm, and you'll have on your seat, you'll have on one armrest a joystick, and you can move it up, back, forward, left, and right. And then you have a button that you can hit so that you get a little bit of boost in case you have to go up over something. And then on the other arm of the chair, you'll have two buttons for turning and rotating the ship. One thing I didn't mention about the pilot's steering wheel is that you will have a button that you hit that is for fuel ball release manually, and then the other button that you hit will give control of the ship over to the landing pilot. Now, I'd like to explain how I came up with this idea. There was a video it was Occupying Mars with Elon Musk, and he explained that with a rocket, what you're doing is you're pushing as much out the back end as possible. And my mind went straight to explosion. Now, I tried this several ways, and I had very many failures, but I had success when I used two small plastic cups, and a firecracker. And when I glued it to the inside of the top of the cup, it exploded. And if you go out too far, you don't get much thrust. But right in the sweet spot, right about there, what you have is a spaceship motor. So I fired that off after I said I lined the end with masking tape, and I put it on very tight, and I made a little cone tip, and I got really good results. I even made a stage 2 with 2 little firecrackers and a metal brace between them, and I had extra wick on one so that it went off one and then the other. And the results were outstanding. There was no damage to the cup, and it got plenty of thrust. Okay, so the next thing will be about the actual size of a fuel ball, about the size of this balloon. It will have a shell, and then inside it there will be C4, and then there will be a little insert like on a basketball where you can pump air into it so that it has air in it to help the ignition. And it'll have a sensor and probably a transponder so that as it gets ejected from the fuel ball clip, when it gets to about right here, it explodes. Now, the next thing I want to show you is the internal components of the spaceship. I made it so that it comes apart so I can show you how it works, but it really doesn't need to come apart. It'll all be one solid piece. In here, you can see the spiraling fuel ball clip comes out to the center, and then it will go through the hole in the battery that will also be the floor of the spaceship. It will have a shell on it, and that will be the floor that you're sitting on. And then it will go through the breathable air and oxygen supply for all of the steering rockets and the landing rockets, which I'll get to in a minute. And then the other half will be for the the fuel for the rocket fuel, and then the top of the shell here will also have a hole so that the fuel balls can slide through. Now, I'll show you the landing rockets before I get any further. Well, basically, you'll have two nozzles because one would have made it bigger and it would be less aerodynamic and more bulky. So I went side by side with two of them, and I'll show you how that system works. You'll basically have something that looks like this inside it. You'll have your nozzle here, 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 and here, and there'll be a valve with a small electric motor that, when opened up, lets the rocket fuel come out, and then there'll be another one here, and then there'll be another one here that gives rocket fuel and thrust to the two landing rockets. So I mentioned a fuel ball clip, and I was going to go with a spring-loaded system that after you load all of your fuel balls inside of here, that spring that kept tension, but I feel like the whole fuel ball clip is too long for that, so I came up with another idea. This being the fuel ball, and this would be the motorized pusher. So basically what that does is it goes in after all of the fuel balls, and it has wheels that are motorized that keep pressure on the fuel balls and push it through. It'll have a sensor to keep tension on it. And then the I'm going to go over the pilot seating now. So you'll have your landing pilot. He'll be sitting like this, at about the middle of the ship, and he'll see straight out, and he'll be able to land the ship. And then in front of him, you will have your steering pilot. He'll be sitting like this, and he'll be looking straight up forward so that when you're flying the ship you can see him. So it'll basically be something like this. You'll have two pilots that are sitting like this, and the chairs will be spring loaded to adjust for the thrust that you will get from the fuel balls. And the landing pilot, when he's not landing the ship, he'll recline backwards to make it easier on his back. So basically what you're gonna have that pushes the fuel balls through will be a little electric motor that will be on a pulley, and it will be a torque motor, and you'll wind it up and wind it up and wind it up, and then there'll be a spring, and when you let go, when you disengage the motor, it'll push down like a pinball machine and push each fuel ball out. And I'll go over next. This is the for the hold on, not thinking of the word, for the force field. Excuse me, there it is, the force field. So you'll have basically a balloon that goes up inside from the top, and then you rub one side down like a balloon that you would stick to the wall, but then you reverse it and you turn it around, and then you push the harness up in so that it surrounds it and kind of pancakes it. Now, I learned from an experiment that when you rub your head with a balloon and stick it to the wall, if you tie that to a string and hang it from the ceiling, and then you try to spin the string, what happens is eventually the balloon will try to hold its place and not turn. But once you get enough tension on it from spinning the string so many times, what happens is if the wall is here and it's attached, what will happen is it will move away really fast, spin really fast, and then reconnect back on the same side. So that's how I'm sure that the whole idea for a static electric force field is sound. Okay, and then another thing is combustion is not possible in outer space. You get a light show, it explodes as light only, like turning on a light bulb. There's no combustion. So what I did with the bottom of the ship, and I'll show you here so you can kind of see what's going on. These will be vents. I left this open so I can explain more to you. But when the fuel balls explode, the spring-loaded vents will open up, and you'll have on the inside of the arms, there'll be holes in the ship that pump air into the ship motor and pressurize it. So once it has pressure in it, then you have combustion, and they'll all open up and release the explosion. And you'll need something kind of like this as a harness. You want it to be thin so that the power of the explosion pushes through easy, but then you'll also want it to be wide so that it doesn't blow out from the explosion. So uses for the gyro bullet spaceship. Well, there's a lot of gold and platinum in the Kepler belt that could be mined and brought back to Earth. It could be used to help terraform Mars. It could be used so that people can go visit other planets. Instead of it taking 6 months, you get to Mars in roughly 8 hours. So that's a doable trip. Another thing is an emergency vehicle. If you have something go wrong in space and someone needs help, a ship that moves this fast will definitely be like an ambulance. A few other things about the ship are that I already said that it's much cheaper, it's much more efficient than a rocket. A rocket won't be completely obsolete because this is only going to haul about 2 to 4 people, and it doesn't haul very much cargo. So the rocket will still be useful as a, so to speak, semi truck of space vehicles. Uh, but this one will be much faster and much more efficient, much more feasible when it comes to taking people to new planets and bringing small bits of supplies little by little. Um, it will definitely be useful. I've heard speculation that the UFO saucer, or the flying saucer, has been allegedly clocked moving 22,000 miles an hour in our atmosphere. It may be faster than that in outer space, and the rocket moves at 17,500 miles an hour, but my ship moves at 31,200,000 miles an hour, which is really a huge leap forward in aerospace technology. I'm going to be sending this video to colleges. I'm open for webinars, seminars, coming to see you in person. And I will also be making this a YouTube video, and I will be making this a video that I send to the National Science Foundation looking for funding to build the actual gyro bullet spaceship. My name is Justin Robert Lentz, and thank you for your time.